Welcome to task 15. Today we're going to use the dry erase board to kind of explain some of these tasks and some of these operations that aircraft conduct within the class Delta. Task 15 is going to go over sequencing aircraft and separation of aircraft. First, we're going to describe how to establish the sequence of arriving and departing aircraft to achieve proper spacing. According to the point 65, we're going to establish the sequence of arriving and departing aircraft by requiring them to adjust flight or ground operations as necessary to achieve proper spacing. There are several ways that we can do that. We can use extensions. If an aircraft's on the downwind, their normal base turn might be somewhere about a mile or so depending on the aircraft characteristics. We can ask them to extend downwind a half mile, 1 mile, 2 miles, or as we need. We can also ask them to extend downwind and tell them that we'll call their base. Zoom 71, extend downwind, I'll call your base. We can also say, if we've already previously issued traffic, we can ask Zoom 71 extend downwind, report traffic to follow in sight. Once they report traffic in sight, we can tell them base turn at their discretion. And that will allow them to provide their own spacing for aircraft on final. We can also ask aircraft to extend upwind. So at Edwards Air Force Base and the 13204, we have actual phraseology for this. We can tell them make extended close traffic. Extended close traffic is 1 mile off the departure end, and then they're going to enter the downwind traffic pattern. However, there are multiple aircraft that come here on a seasonal base or temporary with TPS, or we have aircraft like the F-35s, the C models, and B models that are non-base assigned aircraft, but they're here temporarily. They may not be as familiar with these operations, and so I would recommend that if you give an extension for upwind, instead of saying make extended close traffic, that aircraft reading that back and then maybe only extending a half mile or no extension at all, I would tell them a set amount to extend. Extend upwind 1 mile, then make left close traffic. Or extend upwind 2 miles, then make left close traffic. That'll be a lot more efficient, and it's also not an Edwardsism, so when you go to a new place, that's going to be very helpful for you. We can also ask aircraft to make short approach. So an aircraft that normally would turn a 1 mile base, we can ask them to make a short approach, and then give them the reason why. This is very common if we were to have a C-12 that's here at the approach and downwind, and then we had an F-16 that's maybe just outside 5 miles or so. What we can do then is just tell that aircraft to Zoom 71 or Cobra 241, make short approach, traffic F-16, 5 mile final, runway 23 left, wind calm, clear touch and go. What that allows us to do, we'd want to preface that, we want to preface that with if able. Whenever we do ask an aircraft to do something that is tighter than normal, like an early right turnout or a short approach, we want to preface it with if able. Because if the aircraft is not set up to do this, the aircraft configuration may not be okay with that. We want to throw it out there so they don't feel compelled to make that early approach. Sometimes if we have inexperienced pilots and we tell them to make that short approach and they don't have the proper speed that they need to or time to be set up, they can put themselves in a really unsafe situation, and we may have an aircraft crash if they're not ready for that. And so it's really important to preface that with if able. The other thing we're going to do is we're going to make sure that when we sequence, we're going to use the follow call. And we want to reduce our verbiage as much as possible. If we have an aircraft on the go, and we have aircraft approach and downwind, we're going to issue that follow call. Zoom 71, follow F-16 approach and downwind, close traffic approved. Or Zoom 71, number 2 to follow F-16 approach and downwind, or departure and downwind, close traffic approved. And so that brings up two things, given the follow call and the sequencing number. So what that means is if you have an aircraft that's approaching downwind, aircraft departure and downwind, and an aircraft on final, we'll just say, for instance, this could be number 1, number 2, and number 3. So with how this would work is this would be like Zoom 71, you're number 1, you're number 1. And then this could be like Cobra 21, number 2, follow F-16 approach and downwind, inside of F-16 8 mile final. Let him know that he needs to turn that turn regular instead of maybe extending it too wide. Then this would be number 3, Cobra 21, number 3, follow F-16 departure and downwind. Now it's not a requirement to use the number system, but it is helpful so aircraft understand just how many airplanes are in the pattern and where they fit into the grand scheme of things. So then the next one is traffic. So how traffic works in difference to actual follow call is the aircraft that may be approaching downwind going to turn a regular base for runway 23 left, and then you have an aircraft on final for runway 23 right, say it's a C-12. Their flight path is not going to cross, so this aircraft's not going to be following this aircraft. They're technically separated by the pattern. However, as this aircraft makes that 90-degree turn and looks out and sees a C-12 out here, depth perception is not always going to be easy for them, so they may not understand that this aircraft's going to be landing that runway. So we need to let them know. Zoom 7-1, traffic, C-12, 3 mile final runway 23 right. And we have to specify which runway they're landing at. Also, if this is our C-12, we might say Cobra 1-2, traffic F-16, approaching a left base, runway 23 left. That way we'll let both aircraft know what to anticipate. It gets even more important as they extend out to about a 5 mile base, and you have this aircraft that's out here setting up. There's no set line that aircraft are following on the ground to establish themselves over final. So sometimes what could happen is the aircraft could go past final and then come back in. They're overshooting that final turn. But they'll be less likely to do that or more cautious about doing that if we issue that traffic. Zoom 7-1, traffic, C-12, 5 mile final runway 23 right. Again, we'll be going back to the C-12, Cobra 1-2, traffic F-16 turning a 5 mile left base. Or traffic ahead and to your left, F-16 turning a 5 mile left base. That's the difference between traffic and follow calls. Traffic is traffic that they need to avoid or be aware of that's going to be in their flight path or in their visual range as they're turning that turn. And what I mean by visual range, this is your aircraft, and there's any airplane that's going to be within their visual range as they make that turn. We want to let them know about that aircraft, just so they're aware of what the aircraft's doing and what the aircraft's intentions are, and vice versa to the other aircraft. That will ensure that the aircraft that's outside that pattern, make sure that they fly that pattern correctly. So the next thing we're going to go over is 360s and 270s. What a 360 is, if there's aircraft in the downwind or anywhere within your pattern and you need them to make more space, you can have them do a 360. And that would look like this. Zoom 7-1, make right 360. Now, when we do a 360, we can give a regular 360 if they're on the downwind, or if they're on final, we can have them do a right or left 360. We need to specify that. We're also required to let Sport know. The reason we're required to let Sport know is because aircraft could be behind them coming in that we haven't been inbounded yet. And if we may give an aircraft a right 360, it may mess up Sport's sequencing for us. And so we may need to do something. So we need permission prior, or we need to advise them prior. The other thing to note is that 360s are not defined. It is not going to be a set amount. Depending on type of aircraft characteristics, it could be a smaller 360 or it could be a much larger, if in the event like a heavy is going to be doing a right 360. So sometimes it also helps to let aircraft know what we need to do or where they need to re-enter the pattern at. And how that would look for aircraft on the downwind, let's say they're midfield downwind, what we can do is ask them to make a right 360 and re-enter the downwind at departure end. That would ensure us that we are aware of where he's going to be re-entering the pattern and how it's going to look for us. We can also, when they're on final, we could say, we'll say this is 5 miles right here. We can tell them, Zoom 7-1, make right 360, re-enter final at the tack end. And that way they go out there. I've had a situation before where I've had an F-16 make right 360, hoping I can get a few more miles, and he just cranked it really tight, and then I had to give him another 360. So it's really good to communicate with the pilots and be more specific about what you need from them. If we have the space, we want to be more gentle or more forgiving with our pattern and give us as much time as we can. We don't want to delay the aircraft, but we also don't want to run it too tight. The other thing we can do is a 270. This is very common for us to use a 270 when we're landing aircraft on runway 30 with aircraft on final. So if we have aircraft on final and we have an aircraft that's on the downwind, turning the base turn for Lakebed runway 30, and the traffic is going to be a conflict, what we could tell is this aircraft to fly through final, or Zoom 7-1 carry through final. So if we extend final out here, Zoom 2-1 carry through final, make right 270, and report reestablish on final for Lakebed runway 30, and then we want to specify why. Traffic, heavy KC 135, 4 mile final. So it's really important that we tell aircraft why we want to do something. If we don't tell them why, they're going to ask. And so if aircraft understand the plan, they're easier to use their expertise to help us out. Another situation we could do this with is if we have an aircraft approach in downwind and we want to make them do a right 270 for the base. And again, the reason why, the traffic that we're going to have for them. The next thing I want to talk about is dog legs, squared off turns to final. So what a dog leg is, we're going to assume that this is 5 miles right here, and we have the TACAN out here. It's very common for sport to send aircraft either down final or even from anywhere from the northeast over here. And what's good about that is often what's going to happen is aircraft are going to do one of two things. They're going to either square their turn off, right? So it looks like a 90-degree turn, or they're going to do what's called a dog leg. Okay. More commonly, what this happens is aircraft usually dog leg to initial and square off their turn to final, but it's not set. And so the dog leg is only essentially what it is a non-90-degree turn into the pattern or into the final approach. It usually is like a 45-degree angle. But we can ask aircraft to do one or the other. If the aircraft's out here and you need more separation because maybe there's another aircraft on final here, and if they dog leg it to final, it won't be good for them. We can ask them to square off their turn to final, follow F-16 over the TACAN. Or we can ask them to enter final at a set place, like 10-mile final. Enter final or at 10 miles, traffic F-16 over the TACAN straight in. Or if we have an aircraft that's out here and we want them to beat that aircraft to the runway, because aircraft characteristics say we know how to do that, and we have an aircraft here, we can ask them, if they're already trying to square off their turn, we can ask Zoom 16, dog leg to final, enter final at 5 miles, traffic heavy KC 135, 10-mile final. So that was the way we let them know why we want them to do it and how to get there. If we don't specify where we want them to enter final, they'll enter final wherever they want or wherever they think is best for them at the moment. Next thing we're going to do is define Class D airspace with runway separation requirements. So what that is VFR runway separation. In the Class D, we're responsible for VFR separation. For departures, that means category separation. So for us at Edwards, we're using category separation. I'll give you an example of F-16 versus F-16. They're both Category 3 aircraft. We have to ensure that they're 6,000 feet and the first aircraft is airborne prior to the second aircraft starting departure roll. For arriving aircraft, if there's an aircraft on the runway, we use reduced same runway separation given to us by MAJCOM. And so for us at Edwards, again, depending on type of aircraft, we'll use the example again of F-16. We need 3,000 feet for like a touch and go behind a touch and go, or a full stop behind a full stop. A T-38 is different. It's a trainer type aircraft, and so we'll use 6,000 feet for that. And so what that really means is you're anticipating the separation here, and that's your separation requirement. We're not responsible for airborne separation, but we are responsible for issuing traffic. The other thing that we're going to have responsibility for, or that there is separation of, is wake turbulence separation. If there is a heavy aircraft on final, and you have an aircraft on the downwind, or wherever in your pattern, we are not responsible to provide the separation for this aircraft behind the heavy aircraft. If they need additional separation, they're required to let us know. A good example of that, Edwards, is our T-38s require 4 minutes wake turbulence separation behind heavy jet aircraft. That's not our air traffic requirement. That's that aircraft's requirement. So his responsibility as an aircraft commander is to advise Tower if they need additional separation. What this will look like is you have Cobra 3, the approach and downwind. You say follow heavy KC 135, 2 mile final. He'll come back and say, Tower, we're going to need 4 minutes. And then you let him know how he's going to achieve that 4 minutes. Roger, transition to a south reentry or extend downwind, turn base, your discretion, depending on what we have behind that other heavy aircraft on final. Again, that's going to be the pilot's responsibility to provide that separation. Describe when an aircraft executing a touch and go, stop and go, low approach is cleared, or correction, is considered an arriving or departing aircraft. So an aircraft doing a touch and go is going to be an arriving aircraft until they touch the runway, then they're a departing aircraft. Describe what should be taken in consideration when approving, disapproving a pilot's request to remain in a close traffic pattern. So if we have multiple aircraft in the pattern, depending on how many airframes we have, who's inbound for what, and we have an aircraft on the go, if we cannot approve closed traffic, then we need to let them know why. Unable closed traffic, multiple aircraft in the downwind, and then give them additional instructions. A lot of things that we could do is we could do a south reentry, we could do a north reentry, especially a north reentry to initial, because a north reentry to initial takes them out of the traffic pattern, and when they come back in, they're not interfering with anybody on final. We don't have to worry about trying to fit them into some sort of gap. They're going to go right to initial, and then we can give them instructions from there. The other thing that we can do, if the traffic pattern is just so saturated and we just can't get them in, a good example of this would be like a heavy KC-135. In the pattern, they're doing multiple touch and goes, and we just can't provide the separation for them at the time, or the sequence for them at the time. We can tell them continue upwind, contact Sport for resequencing. And then we'll either let our CT know to do that, or we'll talk to Sport ourselves. And what you want to do is give Sport some sort of guidance about where they want them to enter the pattern. Hey, heavy KC-135, Ghost 71, squawking 0021, coming back to you for resequencing. Bring him out to 10 mile final, or bring him out to the mines for final. The phraseology for that was going to be left or right, depending on what you need, closed traffic approved. Now, what's important to note about this is if you have an aircraft that's been conducting multiple south patterns or multiple left closed traffic for runway 23 left, and we want to switch them to 23 right, we need to emphasize that. Zoom 7-1, make right closed traffic, and then usually the reason why if we can, but make right closed traffic. We need to specify that or emphasize the right versus the left. If it's the first one, then usually they will not question you, and you could just give them that. State when takeoff clearance may be issued before prescribed separation exists. So what that means is if we have an aircraft that's holding short of the runway, and we have an aircraft departure roll, and we can anticipate separation. What's anticipating separation is takeoff clearance need not be withheld until prescribed separation exists if there's a reasonable assurance that it will exist when the aircraft starts takeoff roll. What that means is we have one aircraft holding short, we don't have to tell them to hold short if we think it's going to be reasonably that the aircraft is going to be departure or airborne with a proper separation on the runway prior to this aircraft starting takeoff roll. Again, we're going to use category separation for that. So Cat 3 versus Cat 3, 2 versus 2, and 1 versus 1. Anticipating arrival separation. So say we have an aircraft that's on the runway, and they're looking for that midfield exit, and there's an aircraft on final. Again, if we can anticipate that the aircraft that's going to be exiting at the midfield is going to be off the runway prior to this aircraft touching down, then we can give them that clearance. If we can't give them that clearance, we need to say continue. We cannot anticipate separation with aircraft in lineup and wait. And the reason we can't do that is because aircraft usually that are in lineup and wait, so we have an aircraft that's on the runway to exit at Bravo, and we have aircraft in lineup and wait. When we clear them a clearance, they're already ready to go. Their engine checks have been done. They're just going to start rolling, so we cannot anticipate that separation. So this concludes, this ends task 15. Hope you guys enjoyed it, and let me know if you guys have any feedback or any questions.